So yeah, I'm Anna, and so I work on Node Core, and one of the things that I am most likely to be known for is workers in Node. And so yeah, I want to talk a bit about how we implemented that feature in Node and what it looks like, but also how we got there. So, and I'm gonna start this talk with my first contribution into Node Core, which is not really related to workers at all, but I think it's a pretty good example of how open source can work, and one small thing can improve a lot of people's lives. So I was working on the project that used Node in some way, and so in there we had code that it might have looked like this. I don't know. The point is, set timeout takes two arguments. It takes a number argument that gives the timeout. It takes a function argument that is the code that is supposed to be run afterwards. And well, yeah, if you pass in the wrong arguments, so what it would do on Node 4 and previously is it would wait that timeout, and then it would try to call that other value. For example, in this case, the other 1000 as a function. And because it waited that timeout, it would lose the stack trace of the original set timeout call. So you would basically have no idea where in your code that faulty call was. And so a simple way to address that, and that is actually how I debugged this problem in our application, is you can add a type check to set timeout. So I actually downloaded Node Core source code and added this type check, and with that it worked pretty well. And at that point I was okay, yeah, now if I've done this modification, I might as well open a PR against Node. And so yeah, this is my first contribution to Node, and it's a very simple one, and I think it's a pretty good example of if you have a solution for some problem and you think other people might be able to use that same solution for their own problem, maybe open a PR or an issue on the repo of the library or software that you use. And yeah, so I'm giving this talk, and I'm giving talks about Node.js in general because before I started contributing to Node Core myself, I didn't really know what happened inside of the core community, if you want to call it that. I'm sorry for the breathing, but it's hard to stop. Well, yeah, so I don't know, to be honest, we're kind of an in-group, we might be 100 people or so who mostly know each other, and there's not a lot of people leaving, not a lot of people coming in. And so I like talking about what we do and how we do it, so that people in the wider community have more of an idea of what's happening. Okay, but back to workers. So when I first started writing this talk, just a couple days before or so, on one of our repositories related to workers, somebody wrote this comment, and the gist of it is 50% speed up for my algorithm, workers rock. And loops needed 5 milliseconds before workers. Now they need 2 milliseconds. I have no idea what the actual code is that is behind these metrics, but it's just it's really nice to hear people say, hey, we're using this and it's working great for us, and yeah. So yeah, if you want to understand how workers are implemented in Node, you want to have some background on how Node.js is working internally. So most of the time in typical Node.js applications, you have one process that runs Node code. You have one thread, so it basically means one piece of code runs at a time. This is not exactly true, but it's close enough. You as a JavaScript developer only have one piece of JavaScript code running at a time. You have one event loop that is tied to this one thread, And you have one JS engine instance. So like, for example, in the common case, that is V8. So like one V8 instance, one piece of JavaScript execution, one heap, one garbage collector, all that belongs to that. And on top of that, one Node.js instance. So like one net module, one require function, that kind of thing. None of this really has to be this like one-to-one correspondence, and workers are kind of like a bit about breaking this correspondence up. So like, what's the problem that we're trying to solve with workers? Well, like I said, only one piece of code runs at a time, which like it makes life easy, because like one piece of code running at a time is like it's useful. You don't have like these classical problems that you have when you have threading in other languages. You like don't have race conditions in the same sense. Like you just don't have to worry about concurrency all that much. The downside is, so if you have some very CPU intensive work, again, that is the only piece of code that's going to be running. And if you have multiple processors or processor cores, that might not be what you want, because like you're having unused resources while some other code might be waiting for whatever you're doing to finish. And so the golden rule of writing Node.js applications, or at least for web server style scenarios, is don't block the event loop. Like make sure that other work can progress while you're doing whatever you're doing. And so like you might think, okay, yeah, but we kind of have existing solutions for things like, well, if we want concurrency, if we want full CPU usage, you have multiple processes. So like the cluster API, or just using child process directly. And like these are battle-tested solutions. They work pretty well. And like you get some stability, because like a crash in one of the processes won't tear down the entire set of processes. And well, because like it's basically one single node process every time, you can provide the exact same APIs and everything. It's easy. The downsides of that are mostly like you can't share memory, and for some scenarios you kind of like want that. There's not a lot of that, and like so workers are a solution to a very niche problem, like mostly where you can actually make use of shared memory. The other thing is like we're communicating over JSON. It's okay. Like JavaScript engines have pretty efficient JSON parsers and serializers. But like what we do with workers is actually a bit more efficient and, more importantly, a bit more powerful. So one other solution that we have is worker threads. And these are new in Node. So instead of having one thread per process, you actually have multiple threads. And on top of that, you have, again, one JS engine instance, one event loop, one Node.js instance. So like for the most part, it's basically taking Node and making multiple copies of it inside the same process. And like they are mostly independent, and that also gives some nice properties of this model. And so like the idea of how you can do that is, so workers are basically embedding Node.js into itself. We're trying, like as a project, we're trying to support embedder use cases, like for example, Electron, which takes Node and actually creates a Node instance inside of the process, along with other things that are like completely unrelated to Node. In Electron's case, that's Chromium. But yeah, okay. So in theory, we support embedding. In practice, it's like we're not that good at it, and well, a while ago it has been even worse. Like, yeah, it's definitely something we need help with, and we needed help with. And so, like in practice, before we introduced worker threads, we were running into a lot of the same problems that we were running into with embedding. So like lots of global state, that's not good. It's not an issue if you have only one thread running at a time, but if you actually think about like running multiple threads at the same time and they access global state at the same time, that's race conditions. That's what you want to avoid. We didn't clean up resources on exit. Node.js now does that by default, but a while ago it didn't. And so the downside of that is like if you create workers, you're also in a position where you want to spin workers down, where you want to terminate them, possibly even ahead of time. And you don't want the resources from these workers that were allocated for it to just be lying around because nobody's there to clean them up. And one particularly bad case of global state were CLI options. So basically our CLI options parser was consisting of like a list of 100 global variables or so, and if statements like checking each single case. It wasn't pretty, and like it gets in the way of implementing something like workers, because again we don't want to have global state. People have tried to implement this kind of thing for Node before. Like, I don't know how well known these are, but like in the early days of, I think IOJS it was still at the time. There were 2 PRs by Petka Antonov, and like they added worker support to Node, and like they followed a similar design idea for what we currently have, and they kind of just stalled out because like it was like huge chunks of reviews. I don't have that part of the GitHub issue on the slide, but I think we're like a couple of thousand lines changed to Node, and that's just like very hard to review. These PRs unfortunately just stalled out. There are also like other approaches, like there's a userland module that basically provides web worker style things. In some ways that's easier to implement, in some ways that's also harder to implement. It's not the thing that makes the most sense for a feature implemented inside of Node Core. So a little more than a year ago, there was a fork of Node.js called IOJS, not IO, but IO. So like that happened because like people were unhappy with Node's leadership and a whole bunch of reasons. But the main thing is me and a couple other people started working on worker support in there because that was a feature that a lot of people requested and that never got to happen in Node Core itself. And so we actually worked out a full threading implementation for Node. And it worked at least on Linux and macOS. So earlier this year, this is like half a year later than that, we ported this to Node.js, like all the work that we had already done. And as you can see, like it's still like 4,000 lines added to Node. It's still a pretty big chunk of code. But by now it has like about 270 upvotes and 1 downvote. I think people like it, but one thing to note, and like I don't know if you can see it at the bottom of the slide, but so I'm gonna skip ahead to the third point here, which is like just because I was about to talk about it. So like we're using the module name worker_threads. So use require worker_threads. It's not our first choice. We wanted to get something like worker or workers, but and so like when we introduce a new module into Node Core, there's a good chance that the name we want is already taken on NPM. So like for example, when we introduced HTTP2, there was already a pretty popular HTTP2 module on NPM. And so in that case, what we did was we talked to the author, to the NPM package owner, and said, hey, like we want to have this in Node Core. Would you be willing to give us the name? And they did. And for workers, that was unfortunately not the case. Like the npm package for worker, I don't think it's like popular by now or anything, but like they were like, yeah, but what if it gets popular? Like, I mean, you can have like a lot of discussions around that. We ended up with worker_threads. We're still discussing on like how we do this in the future, and possibly how we do this for workers. Like we're thinking about like scope modules, like @nodejs/workers. Yeah, I'm not a fan of that, but we'll see where it goes. Another issue was like, so like our Windows situation isn't great. I mean, like I don't know if there's software for which Windows support is great, if it's cross-platform, but yeah, that was actually something that blocked us for quite a while, because like there were just like some very, very specific issues with libuv that like worked well enough before, but didn't play along with workers, and just like because nobody was familiar enough with Windows debugging, that stopped work for more than 2 months. We didn't actually have like that much issues with reviewing the PR, even though it was a huge chunk of code. So like I'm really glad about how that worked out. I was kind of afraid that this PR would also stall and just like not end up anywhere, but yeah, it did. And it's available in Node 10 and 11. And it's still behind the flag, but I'm gonna get to that. Okay, so the result, because we have these like very independent Node.js instances, you basically have the full Node.js API available. And in particular, you can require modules. Like this is something that is like this doesn't work in web workers or something like that. It's not quite the same API. It's kind of close to it. It resembles it, but well, because we have like this very different environment inside the worker. So like where you have require, where you have all the standard Node.js APIs available. We weren't going for the exact same API. If you want to, you should be able to implement the web worker API in terms of Node's worker API. And so like it supports like most things that web workers also support. So you can actually transfer array buffers. You can transfer memory from one thread to another. You can actually share memory, and this is like the one thing that that makes workers really stand out. Like you can actually share memory. You can share JS objects, but it's like this is like the fastest way of communication between different JavaScript instances that you can get, basically. And it's like if you want to, you can use it in a way that's very close to what classical threading implementations have. And we have message port and message channel APIs. This is the same thing that browsers use for their web worker API, and it's actually standardized. It's part of the HTML standard, and well, with like minor exceptions, it's like very close to what we have there. And so like this is how the actual API looks like. And I mean, there's more to it than this, but this is basically everything you would need to know. So like we have this module worker threads, and it has like a worker class inside of it and a parent part instance, which yeah, well, it may or may not be defined, but yeah. So you can create workers by either specifying a file name, similar to what we do with the web workers, where you pass a URL to some script that you want to load, or you can pass the eval true option, and so you can actually just put a bunch of JavaScript code as a string in there, and it's going to run that code inside a new thread. The message passing works through, okay, you have worker.post message and worker.on message as an event listener on the worker instance. You have something similar inside the child thread, where you have parent part. And it basically plays the same role. I don't know if you've ever used web workers, but what you have there is that you set like some global variables, like you set the window.onMessage or something like that, to something that would process messages from the main thread. In Node.js, we're not very keen on adding new globals on our own. Like, we think this is something best handled by the language. And so like we don't have this global on-message handler, but instead we provide this parent part object, and you can use that to pass messages back and forth. Okay, so this is an actual concrete example. I think it should just run the way it is. If you want to try it. Okay, this is one of these examples where you pass in a string and actually just run this. It's done this way because like this makes it easier to fit on one slide. You can also just like take the string that is passed to the new worker constructor, put it in a new file. It should just work the same way. But yeah, this is just like an example of how the message passing works. So inside the worker, we are adding an once message handler. So we're waiting for an event to come from the parent thread. And once that comes, we send a message back. Then in the parent thread, we set up another message handler that waits for an event from the child process, from the child thread. And yeah, then we send a message, and that message gets sent back. And it's like in the end, it's very simple ping-pongy kind of thing. You currently still have to use node-experimental-worker to actually run threads that uses this feature. Well, the reason is that, well, as you might be able to guess from the flag name, workers are still experimental, and we kind of reserve the right to make breaking changes to it. So like if for some reason, because like it's a very new feature and it's very deep in the fundamentals of how Node works, we kind of want to have the flexibility to make changes if necessary. I'm going to talk about a bit more about what that means in practice in a bit. Another example, and this is just like, it's slightly more complex. It's like the slides for this talk are linked from the join.in page for this talk. They mentioned it at the beginning of the conference. So like if this is a bit hard to read or hard to follow, maybe just like do that on your own device or something. Well, the gist of it is like, this is an example of how you can actually share memory and make use of that. It's a very contrived example, but still. It's computing the prime factorization of some number. And well, so the interesting parts are here. So you create typed arrays in a specific way. Like you have to use a specific kind of array buffer for it. It's not the standard one, but a shared one, which means it can be shared between threads. And for communication between threads, we actually don't use the message passing API here, but instead we use atomics.notify and atomics.wait. And so like this is very close to what you have for threading in other languages. So like yeah, it's similar to logs or condition variables or something like that. And well, one thing that's kind of like unusual about this for JavaScript is that atomics.wait, it actually waits for the atomics.notify call from the other thread. So like it could block indefinitely. And previously JavaScript didn't have any comments that would, well, just like block a main thread. I mean, this is why it's not allowed in browsers. But in Node we can be a bit more flexible. So yeah. Yeah, I'm not going to go into the details of like what each step here does. Look at the slides if you want to. Okay, it's still experimental. Like I said, we reserve the right to make changes if necessary. And we're kind of like in the chicken and egg situation, as we are with every experimental feature. So like, we want people to use it and to give us feedback about it. Because that is the way we know, okay, this is the right API. This is something that people actually use. At the same time, because it's experimental, we don't want people using it in production yet. And this is the reason why it's still behind the flag. That makes it hard to get feedback. So yeah, if you have anything, there's a link to a to an issue where we're looking for people's experiences and thoughts on the feature. If you have any, please go there. And yeah, or if you just have done anything with workers that you think might be interesting, yeah. By now we actually have DevTools support. That has taken quite a while. So you can actually use the Chrome debugger like you're used to with Node, and you should be able to inspect workers the same way you're able to inspect the standard Node.js processes. We're also looking at maybe implementing the weblogs API. It's a slightly different approach to resource management in multi-threaded environments. So it's actually a promise-based thing where you acquire a log and then you run an async function and then you release it. It's very high level. It's not going to be as performance as Atomics, but it's going to be very very much easier to use, and more importantly, very much easier to not misuse. So you can actually run into real deadlocks with this API, which you can with atomics.wait. But yeah, this is not yet standardized as far as I know. So yeah, this is just something for the future. Also, native add-ons, they don't usually play along very well with workers if they are old and unmaintained, which a lot of native add-ons in the ecosystem are. That's just an unfortunate reality. Because well, if you're writing add-ons for Node and you have been for a while, you might know that sometimes it's just easy to write code using global state, because if it's a single-threaded environment, this is just not an issue. And it sometimes makes things easier to write. But yeah, this interacts badly with workers. It's when you're using add-ons, take care. We're working on improving support for it with workers. But in the end, add-on authors may need to modify their code to work well with workers. One piece of the web workers, not of the workers API, is that we have the possibility to stop a thread ahead of time. We use .terminate for that, like web workers do. And so one issue with that is that a lot of Node.js code is written with the expectation that some parts of JavaScript just can't fail. So what I mean by that is when Node.js calls into JavaScript from C++, sometimes it calls internal functions or something, just like helper functions that are easier to write in JavaScript, something like that. And if we know that that function can't fail, then that won't throw an exception. Then we can just say, okay, yeah, whatever. We don't need to handle error conditions coming from that call. And just crash the process otherwise, because then it's a bug in Node, and well, that's what we do for C++ bugs in Node. We crash the process. With workers, that's no longer true, because being able to use .terminate means that any piece of JavaScript can now theoretically fail, because terminate is basically saying to the JS engine, please stop everything you're doing right now. It kind of works like an exception that can't be caught, and so we need to handle this from C++. And yeah, basically we need to do an audit of all of the Node.js C++ source and make sure that this doesn't interact badly, which hasn't happened yet. So yeah, that's also something we're waiting for in order to exit our experimental status. So some features that might be a bit more out there. It's so one thing that you can do with child processes is you can actually pass around native handles like network sockets, something like that. That should be doable with workers. It's just not implemented yet. And doing it in a clean way would require some changes to libuv that just take some time. We're also thinking about deadlock detection. That requires some support from the engine, and yeah, this is just something that's on my to-do list. I want to make that happen because like it's I think it's not great that now you actually have the possibility of getting deadlocks in JavaScript applications. Yeah, you didn't have that before, and it's like not a very JavaScripty kind of problem. Like we just like are not used to handling this kind of situation from JavaScript. There have been other approaches like happening at the same time, like to the general problem. So like Alibaba and Microsoft both have worked on workers implementations that go a lot further. And those actually require engine modifications. And the goal is to actually be able to share JS objects. So instead of just being able to share some typed arrays or some memory, you can actually transfer objects from one thread to another, or make them or make them like concurrently accessible. That's a very fancy feature to have, but it's nothing that we can do on our own, because like the standard V8 engine, it just doesn't support that, and I don't think any JS engine does, currently at least. And so like this is a much bigger conversation that probably also needs to happen at the language level. Nothing for Node to do on its own. Like, please don't think this makes everything magically faster, workers. It's still like, well, so for one, if you use like the async IO node, that's the right thing to do. Like if you want to do something like spawn threads and do synchronous IO from them, which I'm afraid people might want to do because like they're used to it from other languages. It's definitely not going to be more efficient than what Node already has. Node's async IO is pretty good, and like doing IO from workers in parallel, it's not going to be faster, it's not going to be better. Please don't do it. Also, it's not cheap to spawn workers, because like if you remember from back earlier in this talk, we're basically spinning up independent node instances. And so like that still takes quite a bit of time. Like, I mean, a couple of milliseconds, you know, but in the big picture, it's still a bit of time. A friend of mine actually benchmarked this after I gave this talk last week. She came out with a number of like, it's 30 to 40% faster than child processes, which I'm happy about, and like it's great to hear that, but it's still not like super fast or anything. We're working on improving the startup performance of Node. Mostly she is, to be honest, but yeah. So like if you actually are in a situation where you're tempted to spawn a lot of workers, don't do that. Use worker pools, like have some available and send messages to them and wait for answers instead of spawning new ones. Actually, back there in the very corner of the room, there's the author of an NPM module called microjob that is like, it's a utility wrapper around our workers implementation, and it has some built-in support for worker pools. It's like, maybe look into using that. Okay, that's it.